All right, this is a limiting reagent or a limiting reactant problem. We've got the problem here. It says how many moles of sodium nitrate can be produced by the reaction of 25.3 grams of sodium metal with zero point 0.6 moles of calcium nitrate. We're going to find out which reactant is holding us back, what's our limiting reactant, which reactant is in excess, and how many moles of the excess reactant will we have left over. So a couple of things here, but since this is a limiting reactant problem, anytime we've got stoic, what we want to look at is a balanced chemical equation. So we've got to somehow pull a balanced chemical equation out of here. So here it says how many moles of sodium nitrate can be produced. So if it's being produced, most likely it is, I need a paintbrush there. Most likely it is a product. So we've got sodium nitrate being produced, and what are we producing it with? It looks like sodium metal, the reaction of sodium metal, that's just Na, and we don't have to worry about Hunkelbrief or anything because, well, sodium's not one of them. And then calcium nitrate, so we got calcium nitrate. What's my formula for calcium nitrate? Calcium's a +2, nitrate's a -1, so we're going to crisscross my -1. My 1 becomes a subscript for my calcium, and my 2 comes my subscript for my nitrate. And then this looks like it's going to be in the makings of a single replacement reaction. We've got to balance this out with some calcium over here, right? Our calcium and our sodium are swapping places. So not a Hunkelbrief, so it's just plain old Ca. So we got one calcium and one calcium. We're good. We've got two nitrates, but we only have one nitrate over here. So to throw 2 out in front will balance this up. And then we've got one sodium and 2 sodiums over here. So to balance this, let's get a 2 out in front of there. So that's my balanced chemical equation. I want to know how many moles of this I can produce if I have 25.3 grams of this and 0.6 moles of this. So I'm going to set it up as 2 different problems. So I'm going to take our 25.3 grams of sodium, and I want to convert this into moles of sodium and ultimately into moles of sodium nitrate. So 1 mole of sodium has a molar mass of 22.990 grams of sodium. And now I want to change this moles of sodium into moles of sodium nitrate. So what's my relationship here? It looks like it's just a plain old 1-to-1. So 2 moles of sodium for every 2 moles of sodium nitrate. So if I do the math here, this should give me, looks like 1.1, 1.1, not 1.0, erase that over there, 1.10 moles of sodium nitrate if we start with that. Now here we're going to do, we're going to see how much we can create with 0.6 moles of calcium nitrate. So 0.6 moles of calcium nitrate. We want to change that. We're already in the moles there, so we're just going to use our balanced chemical equation and compare these two. We're going to change calcium nitrate into sodium nitrate. So we've got a 1-to-2 ratio, 1 mole of calcium nitrate for every 2 moles of sodium nitrate. So if we do the math here, we should end up with 1.20 moles. I think I gave you an extra sig fig. So 1.2 moles of sodium nitrate. No 2 there, sorry. So what's holding us back here? It looks like our limiting reagent is our sodium. With this much sodium, we can only produce 1.10 moles. If I have 0.6 moles of calcium nitrate, I can produce more of it, but it looks like run out of sodium first. So I'm going to stop this one here, and then we'll look at how to figure out which one's in excess. Well, we just found out which one's in excess. We're going to find out how many moles of excess reactant we'll have left over.